Okay, in this video we're looking at vector projection. Now this can be one of the more confusing parts of vectors, but if you follow the formulas you'll usually get the right answer. I want to talk briefly about what vector projection is. So we'll normally see a vector, it looks like this, let's call it A. And we're used to projecting vectors anyway, because we talk about the horizontal and vertical components of the vector a lot. This horizontal component is like a projection onto the x-axis. So it's like I've taken the vector and I've looked at its shadow down onto the x-axis. And what it's sort of doing with that shadow is it's making this vector along the x-axis there. Same as the vertical component, it's like making a shadow onto the y-axis. And then it's like projecting that vector up there. So we know about projections already, we just haven't formalized it. So that's the idea behind it. And you can see the book does a much better job of drawing the picture than I do. So if you took the vector like 2, 3, for example, like if A was 2, 3, then this vector projection onto the y-axis would be, well, you wouldn't have any x, but you would still be going up 3 in the y, for example. Same as this one, this would be 2 in the x, but 0 in the y. But you can actually project a vector onto any other vector, so it doesn't have to be one of your axes. You can just shine it in any direction you want like this. Okay, so there's a formula for it. There it is. But using what we learned from last time, because we know cos of theta equals a dot b over mod a and mod b, you can actually rearrange this formula to get this one down here, which is the one that you'll use more often than not. So let's see if we can find this. So we're basically going to be using this formula, a dot b over mod b squared times the vector b, and that's going to give us our projection vector. Let's just call it, let's not call it anything, let's just work this out. All right, so we're going to work out a dot b first, so that's going to be 2 times minus 3, and then 3 times 5 over mod b squared. So that's going to be the square root of minus 3 squared plus 5 squared, and then we're going to square that. And then we're going to times it by the vector b, which is minus 3, 5. So we are going to get a vector out at the end of this, because that whole big messy thing is a number, but then we're timesing a number by a vector, so that gives us another vector. All right, so what are we going to get? Minus 6 plus 15. And then on the bottom of this fraction, we're going to get square root of 25 plus 9, so square root of 34 squared, times minus 3, 5. And if we take a square root and square it, well, we're just going to get the number on its own. So that's 34 on the bottom, and then we're going to get 15 take 6. So we're going to get 9 over the top. 9 over 34 minus 3, 5. And if you want to write that as an actual vector, what you can do is you can write it as well. 9 times minus 3, so minus 27 over 34 is your top component. And then your bottom component is 9 times 5 on the top, so 45 over 34. Just like that. So that's our projection vector. There it is. And we also want to state its length. So you could use the modulus formula here to find the length, the modulus of that, or you could use the formula that the question gives us, whereas its length is the modulus of a dot b over the modulus of b. So length is basically going to equal mod a dot b over mod b, which is going to be mod of, well, we already did a dot b before, it was 9 over mod b was root 34. All right, now, how do we take the modulus of a number? Well, all right, there's a couple ways to think about this. 9 is kind of like a vector, but it's a vector like we're normally used to seeing 2 by 2 vectors, so like x and a y, but you can have like 3 by 3, x, y, and z, or you can just have like a one-dimensional vector like that. So 9 is kind of like a vector 9, and if I want to find the modulus of that, it'd be root 9 squared, which is 9. So basically that becomes 9 on the top. Now that's a pretty hectic way to think about it. One way you can think about modulus of a number is that, like, well, modulus of 9 we've seen is 9. Modulus of minus 3 is positive 3. Modulus of 1 is 1. Modulus of minus 74 is just positive 74. The modulus sign when you're dealing with a number just throws away the minus sign. That's all it does. So that's what we get here, 9 over root 34. And that's done. So that's the length.